I want you to picture something for me. You're standing on a rooftop in Shibuya, Tokyo. It's late afternoon, and you've got your phone out. You snap a picture of the skyline, just as the sun is dipping below the horizon. It's beautiful. You get that deep orange light hitting the buildings, the long shadows. It's a perfect moment, frozen.
That's the classic shot, right? The I made it travel photo.
It really is. But here's the question, and this is what kept me up after reading today's source material, is that photograph reality.
See, 99% of people would just say, of course it is.
Yeah.
It's a photo, it's a document. But if we really dive deep into the papers we have today, which is this fascinating kind of headache-inducing mix of philosophy and hard physics, the answer is a pretty firm no.
Welcome back to the Deep Dive. Today we are unpacking a stack of notes that propose a framework called the three worlds. And honestly, this stuff is a bit of a brain melter. It argues that we've made this massive category error in physics, that we've confused our maps, the math we do, with the territory, which is the actual physical universe.
And this isn't just, semantic nitpicking. The source material argues that this confusion is actually breaking our understanding of time, of light, even relativity.
It's a huge claim. Basically, they're saying that some of the most famous diagrams in our physics textbooks, like the light clock experiment, they might just be cartoons of math, not drawings of what actually happened.
Right. And to even begin to understand why a diagram might be lying to us, we have to start with this three worlds theory. The author is very, very strict about it.
So let's walk through them. World one, the mathematical world. This is the abstract layer, right?
Correct. World one is the world of pure logic. It's axiomatic. Think about the geometry you learned in high school.
Okay.
The Cartesian coordinate system, that infinite grid of X, Y, and Z that we imagine would just exist.
The invisible grid,
In our heads, yes.
Yeah.
And in this mathematical world, everything is strictly defined. You have point A, you have point B. You can calculate the distance between them instantly.
And instant is the key word there.
It is. In a math problem, there is no speed limit. Information propagation is immediate.
So truth in this world just means it's logically consistent.
Exactly. It doesn't have to be real. It just can't contradict itself. A 10-dimensional hypercube is true in world one, even if you can't, build one.
Okay, so that's the abstract rules. Then we get to world two, the physical world. This is where we live. This is the coffee spilling on my shirt.
This is the messy, real stuff. Processes, energy, matter. And the absolute dictator of world two is c the speed of light.
So unlike the math world, nothing here is instant.
Nothing. And that is the fundamental disconnect. In the physical world, if something happens here, nothing over there can know about it until a signal physically travels the distance. There is always a delay. Always.
Right, so the formulas are just models of the world.
They're not the world itself. And that's the mistake we keep making.
Okay, but there's a third layer, world three.
World three is the observational world. Or you could call it the measurement world. This is just the data. It's what hits your retina or your camera sensor.
So this is the only world we can actually touch. I can't touch physics directly. I can only touch the data my senses give me about it.
Spot on. And world three is messy. It's flawed. It depends on your resolution, your frame rate, your error margins, all of it.
So we're trying to figure out world two reality.
By looking at world three, our data.
Using the tools of world one. The math.
It's like a crime scene investigation where the detective is wearing distorting glasses and using a map of a different city.
That's a good way to put it. We keep taking ideas from World 1, like that instantaneous grid, and just pasting them over World 2.
We pretend the universe has this invisible grid where we know where everything is right now, but the universe doesn't have that.
And that leads directly to the simultaneity problem. The notes use this great example with the Sun, Earth, and Mars.
A classic setup. So imagine you want to make a model of the solar system. You get out a piece of paper that's world one.
Okay.
You draw the sun, Earth, Mars. You draw a triangle connecting them. In your drawing, on the paper, they all exist at the same moment.
Yeah.
Let's call it T-tires.
Right, I'm looking at the paper. They're all there, together.
But physically, in world two, that triangle is impossible.
Because of the delay.
Because of the delay. If you're standing on Earth, you're not seeing the sun as it is now. You're seeing the sun as it was 8 minutes ago. Mars. Maybe 15 minutes ago, depending.
So my now is completely shattered. It's fragmented.
And the notes use a great analogy for this. The North Star. Imagine the North Star is an observer looking down at our little solar system. And suppose a beam of light from the sun, a beam from Earth, and a beam from Mars all arrive at the North Star at the exact same instant.
Okay, so for the North Star, that's a simultaneous event. It sees them all pop up at once.
For the North Star's observation, that's World 3, yes. But think about the travel time.
Ah,
For
right.
those three beams to arrive together, they had to leave their planets at wildly different times in the past. The sun's signal left hours before the Earth's.
So simultaneity is just a trick of perspective. It's an arrival time thing, not an existence time thing.
Precisely. And this is where the source introduces a concept that I think is the key to this whole deep dive, the external reference.
It sounds like a sci-fi villain.
It kind of does, but it's really just a requirement for doing math. Because there's no universal now, we have to step outside the system to even begin describing it. We need an external reference to set the stage.
This is where the Blender analogy came in. I actually love this because I used to mess around with 3D modeling software.
Oh, perfect. So you know the feeling.
I do. I'm sitting in my chair.
Yeah.
I am outside the computer screen. I am definitely not in the game. I am the external reference. I define the coordinate system. I place the sun object at Fourier. I'm literally setting the stage in World 1.
And you, the user, can see the entire scene instantly. If you rotate the camera, the whole universe just spins. You're God relative to that computer file.
Right, and the source has a name for this, the active voice. Coordinates don't just exist. I have to point and say, this spot right here, that's 0.
So the external reference is strictly a World 1 entity. It exists in the math, outside the physics.
Okay, but here's the rule. You cannot confuse the external reference, me, the Blender user, with an observer inside the simulation.
That is the lethal mistake. Because the Blender user has instant, godlike access to information. A character inside the simulation, let's call it a puppet, does not.
The puppet is bound by the rules of the engine.
Or, in our case, the speed of light. If you treat that puppet as if it knows everything instantly, just because you do, you've broken physics. You've confused the map with the territory.
Okay, let's bring this back to the real world, back to that Shibuya sunset photo. We said the photo is World 3, our observation. The source talks about this window plane.
Right. Your retina, a camera sensor. It's a 2D slice of reality. The source calls this the window. You're flattening a 3D world plus time onto a 2D surface.
We know that, though. A picture is flat.
But think about the time involved. The source argues a photograph captures points of equal arrival time, not equal existence time.
Unpack that. Equal arrival time.
Okay, think about the light rays hitting the camera. The light from the railing right in front of you left that railing, say, a nanosecond ago.
Okay, yeah.
The light from the sun in the background left the sun 8 minutes ago. But they both hit the sensor at the same instant to create the image.
Wow. So the photo is actually a time capsule. It compresses 8 minutes of history into a single flat moment.
It flattens deep time onto a flat plane. Now, usually,
Yeah.
who cares, right?
Right.
But the source says if you treat this photograph, this 2D map, as a true representation of spatial reality, you're making a huge category error.
Because if I take a ruler to the photo, I'm measuring a line on paper. But in physical reality, the sun in the building never existed in that state at the same time.
That's it. In the mathematical world, we can project them onto a plane instantly. But in the physical world, that projection is an illusion. It's a perspective effect caused by all those different time delays.
It's like seeing a star that burned out a million years ago right next to a street lamp that turned on 5 seconds ago. They look together, but they're not.
Exactly. And we get that for stars. But the source argues we forget it when we start doing physics on moving objects.
Which brings us to the subject hierarchy. Subject 1, Subject 2, Subject 3. This felt like a way to formalize the Blender analogy.
It is. Subject 1 is the calculation space. That's reality, the engine.
Okay.
Subject 2 is the monitor, the projection, the display.
And Subject 3.
Not the observer, the person watching the monitor. And the argument is we as humans doing physics are always Subject 3.
We're always just looking at the screen.
Always. We're looking at Subject 2, our data, our measurements, our photos. But we keep trying to make these grand statements about Subject 1, the underlying reality, using the logic of the screen we're looking at.
We're trying to reverse engineer the 3D world from the 2D screen, but we keep forgetting that the screen has lag.
And that lag isn't uniform. The top of the screen shows data from 8 minutes ago. The bottom shows data from now. If you treat that as one snapshot, your model gets distorted.
This is a perfect setup for the controversy, because so far this is philosophical. But the source aims this framework right at special relativity, specifically the light clock.
And this is where the dive gets a little dangerous. They're challenging a foundational thought experiment.
So just to be clear, they're not saying relativity is wrong.
No, but that the diagram we use to teach it is deeply misleading.
Okay, so for anyone who might be a bit rusty, let's run through the standard light clock. I'm on a train.
You're on a train moving sideways. You have a flashlight on the floor, a mirror on the ceiling. You shoot a pulse of light straight up. It hits the mirror, comes back down, tick-tock.
Simple enough. To me, on the train, it just goes up and down.
But now I'm standing on the platform watching your train whiz by.
So from your perspective, since the train is moving, by the time the light hits the ceiling itself has moved forward.
Right. So to me, on the platform, the light doesn't go straight up. It travels a diagonal path, a hypotenuse.
And a diagonal line is longer than a straight vertical line.
And the speed of light is constant. It can't speed up to cover that extra distance.
So it must take longer for the light to make the trip, which means my time on the train has slowed down.
That's the textbook derivation of time dilation. It's elegant, famous.
So how does the three worlds theory attack this? It seems pretty solid.
The source argues that this diagonal line, the diagram itself, it's a construct of world one of math, not world two, physics. They call it a drawing of math, not a drawing of reality.
How so? I mean, if the train moves, the light does have to travel farther, doesn't it?
The source asks a really specific question. What is that diagonal line, physically? The drawing assumes we can track a single photon's trajectory from a God's eye view, an external reference. But in the physical world, a flash of light isn't a dot moving along a line.
It's a sphere.
It expands as a sphere, a wavefront. So when we draw that specific diagonal line, we are connecting a point at time 0 with a point at time 1.
Yeah.
Using a ruler, or making a geometric triangle.
Huh.
But who is seeing this triangle?
The observer on the platform.
But the observer on the platform is also bound by the speed of light. You can't see a photon moving sideways. You can only detect it when it hits your eye. The diagram implies an instant, all-knowing viewpoint that doesn't exist in physics.
So the diagram itself is from the illegal God's eye view.
That's the first critique. And there's a second one, the missing track. The source brings up the rail reference frame.
What does that add to the picture?
Well, the standard explanation only talks about the train frame and the platform frame. It kind of ignores the medium, the vacuum, the electromagnetic field that the light is traveling through. The source calls this the rail frame.
The track itself.
Right. And the argument is that light travels relative to the field, the rail. It doesn't know it was fired from a moving train. It just enters the field and propagates at sea.
So the standard model is treating light like a ping pong ball that carries the train's momentum with it.
Not quite, but the source argues the geometric construction implicitly obscures the physical propagation. They claim that what we call Lorentz contraction objects appearing shorter might actually be a perspective effect.
Like the photograph.
Exactly like the photograph. If you take a picture of a moving object and the light from the back takes longer to reach you than light from the front, it's going to look distorted. The source suggests Lorentz contraction is a similar artifact caused by projecting a 3D reality with time delays onto our 2D observation window.
That's a massive claim. They're not saying the math is wrong, the equations work, but that our visualization of why it happens is flawed.
It's an epistemological critique. It's about how we know what we know. They're saying we mathified the problem. We forgot that the time axis on a graph isn't a physical thing. It's a measure of information delay. We mistook the map for the territory.
It all comes back to the act of voice. We, the physicists, grew that diagonal line. We acted as the external reference.
And then we forgot we were the ones holding the pen. We assumed the universe drew the line for us.
This whole framework really forces you to be humble. You can't just be the eye of God.
You have to declare your position. You have to admit, I am an observer outside space and time defining this system for my own convenience. If you don't, you start believing your conveniences are physical laws.
It completely changes how you think about time.
It does. In this framework, time isn't this river flowing through the cosmos. It's mostly just the gap between something happening and you finding out about it.
That makes the universe feel disconnected, or at least incredibly local.
Hyperlocal is the right word. My now is mine. Your now is yours. The universe's now doesn't exist physically.
Yeah.
It only exists in the World One model we build to cope with the delay.
That's a trip. It means every time we look at a sunset, we're looking at a history book, but all the pages have been shuffled together.
And we have to be very, very careful not to read that shuffled book as a description of the present moment.
So, if the map is not the territory, where does that leave us?
With a challenge. The source ends by asking us to re-examine our proven concepts. We talked about the light clock, but what else?
Right. If that diagonal line is just a map we mistook for reality, what other lines are we drawing?
That's the dangerous question. Are there other laws of physics that are actually just artifacts of our coordinate systems? Things we think are world two truths that are actually just world one conventions.
It makes a lot of solid ground feel a bit shaky. But I guess that's the point of a deep dive, to check the foundation.
Keep questioning the map and always check your external reference.
On that note, next time you watch a sunset, ask yourself, when is the sun I'm seeing right now? The answer is definitely not now. Thanks for diving deep with us.
Always a pleasure.
See you next time.